Engine failure in Chevys isn't always caused by driving habits or bad parts. Many problems start with factory settings buried in the vehicle's menus. These controls quietly increase heat and wear every mile. I've seen low-mileage Chevy engines fail early because of them. The first setting most Chevy owners never question is also one of the most damaging when left on. When Chevrolet rolled out active fuel management, sometimes called displacement on demand, the idea was simple: shut off half your engine cylinders under light load to save fuel. On V8s like the 5.3-liter and the 6.2-liter in Silverados, Tahoes, and Suburbans, and many other GM trucks and SUVs, AFM could shut down 4 cylinders on the highway to eke out a few extra miles per gallon. Here's the interesting part. In theory, this sounds great, but in real-world use, this feature has become one of the most common reliability headaches Chevy owners run into. I've noticed that the first sign of AFM trouble is a persistent ticking or tapping noise from the engine as the system switches modes. This is usually because the lifters wear out or collapse. You see, AFM lifters are far more complex than standard hydraulic lifters, and they depend on clean, stable oil pressure to work right. When those lifters fail, the valve train doesn't operate right, leading to rough idle, misfires, and even camshaft damage if left unchecked. Many Chevy owners have dealt with excessive oil consumption and misfires on AFM-equipped engines, sometimes before they hit high mileage. Once you start getting lifter damage, it often requires removing the heads to fix, and that can cost several $1,000s in many shops. Many owners with a Silverado 5.3-liter engine found low compression on a cylinder and realized it was because of a failed AFM lifter and worn cam lobe. So what can you do about it? If you want to keep AFM from shortening your engine's life, keep oil changes frequent with good synthetic oil at a tighter interval than just 7,500 to 10,000 miles. You should also monitor the oil levels regularly because clean oil is very important to how AFM's lifter system works. But of course, the most reliable long-term solution is a true AFM delete during a rebuild. Although this would be pretty expensive. You might have to replace the specialized AFM lifters and cam with non-AFM parts or use an AFM disabler that keeps the computer from ever switching cylinders. It's important to note that a disabler does not fix worn hardware. But there's another setting related to the AFM which ruins your Chevy, and that's the frequent mode switching. Aside from the active fuel management, Chevrolet introduced its newer sibling, dynamic fuel management, with the idea of boosting highway fuel economy by shutting off cylinders when full power wasn't needed. On engines like the 5.3-liter and 6.2-liter V8s in Silverados, Tahoes, and Yukons, these systems can switch between full power and reduced cylinder modes many times per minute, as often as 50% to 80% of highway cruising depending on how the controller sees throttle and load. The main problem is constant switching, turning the cylinders off and on thousands of times during a typical drive. This puts stress on components that weren't designed to cycle like that forever. AFM DFM uses specialized lifters and solenoids to deactivate cylinders, and those parts wear faster than normal lifters because they're constantly opening and closing under oil pressure. Over time, this cycling eats into the lifters, cam lobes, and other hardware, and once those fail, you can end up with ticking noise, misfires, and in the worst cases, catastrophic engine damage that costs way more than any fuel savings. A lot of Chevy truck owners have noticed how the engine drops and picks up power a lot under light cruise, without realizing that that's the switching happening in real time. One Silverado owner realized that his 2018 5.3-liter engine started burning oil and ticking around 110,000 miles, only to realize that it was because of frequent AFM transitions on long highway trips. I've noticed that many Chevy drivers run into this when they do a mix of city and highway driving, where the ECU keeps flipping modes based on tiny changes in throttle. But the problem is you can't stop the system from constantly going on and off unless you choose a true mechanical AFM-DFM delete or use a quality disabler device. Another way is to reduce the stress by keeping oil fresh and at the right level, changing it sooner than the oil life monitor suggests, and watching out for early tick or misfire symptoms. So, if you're planning to keep a modern Chevy engine long-term, You need to pay attention to these features and avoid costly engine repairs down the road. Hey everyone, I'm Jerry. Over 30 years I've worked on Silverados, Tahoes, Suburbans, and just about every Chevy V6 and V8 you can think of. I've seen hidden features that destroy reliability and shorten engine lifespan, and I'm here to help you get more miles and avoid expensive repairs. Let's explore 11 hidden Chevy settings that are quietly ruining your engine reliability, continuing with number 3. When Chevrolet started using gasoline direct injection on engines like the Ecotec 3 5.0-liter and 6.2-liter V8s in Silverado and Tahoe, or the 2.0-liter and 1.5-liter turbos in smaller Chevys, they gained better power and fuel economy. GDI sprays fuel directly into the combustion chamber under high pressure, and that's supposed to be great for efficiency. But there's just one problem. The fuel never washes over the intake valves like it does in older port-injected engines. That means the natural cleaning action that's supposed to stop soot and oil vapors from sticking to valve surfaces doesn't happen anymore. Without fuel washing the back of the intake valves, carbon deposits build up over time from oil vapors and blow-by gases coming through the PCV system and normal combustion byproduct. I noticed this downside of GDI technology happens because the valves are unwashed and hot, causing sticky carbon buildup. Many Chevy owners have realized that as mileage climbs, this buildup shows up as rough idle, loss of throttle response, lower fuel economy, and hesitation under load because the carbon literally chokes airflow into the combustion chamber. Chevy drivers often notice this issue first in turbocharged GDI engines like the 2.0-liter Ecotec in Equinox or Cruise. They might need walnut blasting or serious intake cleaning near 80,000 miles to 100,000 miles depending on their driving habits. One owner of a 2016 Cruise 2.0 turbo noticed power loss and stubborn misfires only went away after a walnut shell blasting service on the intake valves, something that simple fuel additives never actually fixed. But remember this, fuel system cleaners in the tank don't reach these valves in GDI engines, so don't expect a bottle of additive to eliminate the problem. Instead, you want to keep your Chevy reliable, keep tight oil change intervals, use top-tier fuel, and consider an intake valve cleaning or walnut blasting every 60 to 100,000 miles as a preventative measure. I also recommend adding an oil catch can to reduce the oil vapors reaching the intake, which can slow down deposit formation. But there's another feature in Chevrolets that easily drives users crazy and can affect engine reliability, and that's the piston rings. When some Chevy owners complain about oil consumption and engine life, one contributor in specific engines has been the piston ring design. This is most famously an issue on certain Generation 4 5.3-liter V8 engines built around 2007 to 2014, where the combination of piston ring design, crankcase pressure systems, and other factors led to unusually high oil consumption that GM has acknowledged. Piston rings are literally the gatekeepers between the oil in the crankcase and the combustion chamber above the piston. When they don't seal properly, oil can bypass them, be burned in the cylinders, and force you to add oil frequently while exposing the engine to low oil stress. I noticed that on the Generation 4 5.3-liter V8 engines found in some Silverados, Tahoes, Suburbans, Avalanches, and similar models, GM used low-tension oil rings that could become clogged with carbon and lose their ability to properly control oil. This can contribute to consuming a quart of oil every 1,000 to 2,000 miles in the worst cases. Many Chevy owners have had scenarios where the engine burns excessive oil and leads to fouled spark plugs, carbon buildup, and more frequent oil top-ups, and in some serious cases required piston ring replacement or even a short block. When piston rings let oil get past them, you'll often notice bluish smoke on acceleration, frequent oil top-offs, and spark plugs coated with oil from the combustion chamber. Over time, the carbon builds on valves and plugs, which can cause misfires and reduce performance. This situation is made worse when oil levels run low because contaminated or insufficient oil can't lubricate bearings and lifters as well, accelerating wear in other engine areas. Some good practices to consider include checking oil levels much more frequently than normal, even at every fill-up for problematic engines, and shortening oil change intervals with high-quality synthetic oil to keep the soot and deposits from building up. It's also a good idea to keep the PCV system functioning right, as a clogged or malfunctioning PCV can draw more oil into the intake and combustion process. I recommend getting a compression test if you suspect there's a problem with the piston rings. This is far more accurate than assuming ring issues without testing. If you own one of these specific Generation 4 5.3-liter V8 engines, then this is a known issue to watch for. This is one of the Chevy features that cause a lot of trouble, but the next problem is one that most drivers don't even think about. Plastic intake manifolds on Chevrolets is a pretty stupid feature that soon turns into a performance and reliability headache. On V8-powered Chevys like the 5.3-liter Vortec and Ecotec 3 engines in Silverado, Suburban, and Tahoe models, GM used a plastic intake manifold and plastic-style gaskets to save weight and costs. But there's a potential long-term problem. Plastic is fine in many places, but in the heat and vibration of a truck engine, it's definitely not as stable as metal, and that's where issues start. A lot of Chevy owners end up with cracks or gasket deterioration as their engines get older. The plastic material can warp, shrink, or simply become brittle over years of heat cycles, and the gaskets that seal it to the cylinder heads eventually degrades much faster than any metal part. This creates air leaks, unmetered vacuum, and lean conditions that disrupt the engine's air-fuel balance. And before you know it, your engine has a rough idle, power loss, poor fuel economy, and a check engine light with lean codes like P0171. Air leaks around the plastic intake won't only reduce performance, but they make the engine work harder and burn fuel less efficiently. Misfires and idle surging are common symptoms because the engine computer can't correct for the erratic airflow. You might think you can solve this problem with a sealant, but these don't hold up long at engine temperatures. The best thing to do is replace it with a new OEM manifold or a quality aftermarket unit when it fails. In some cases, an aluminum manifold is an upgrade option. While the problem of this feature seems clear, the next Chevrolet problem affects your car the more you use it. Auto Stop Start is the feature that shuts your engine off when you come to a full stop, like at a light, and then restarts it automatically when you ease back on the throttle. On newer Chevys like the Equinox, Malibu, Silverado, and Colorado, the idea is to save a bit of fuel and reduce emissions in urban driving. But this convenience comes with trade-offs that most Chevy drivers don't realize at first. The system might feel handy in city traffic, but it adds significant extra cycles to the starter and battery, though these components are designed to be more robust than older units. Each time the engine stops and starts, the starter motor spins the crankshaft back to life. While designed for this duty, all the cycles of starting and stopping put extra stress on the starter, battery, and some internal parts like bearings over a very long period. City commuters often hit the system dozens of times in a single trip, but many Silverado and Colorado owners disable the feature manually because they don't like the engine turning on and off every few blocks, and they're worried about reliability issues. Though major failures directly caused by start-stop are not widespread, for turbocharged engines, some owners worry about oil pressure cycling and its effect on turbo bearings. While the system typically only engages when the engine is warm and oil pressure is stable, it's a concern for some. So, if you're in city traffic daily, turning auto start-stop off if you prefer can reduce unnecessary starter cycling. Whether it significantly extends component life is debated, but it's a common owner preference. This is a feature you might not expect, but the next problem is one that might just be your transmission. One of the worst transmissions you can have on your Chevy is the 8-speed automatic, like the 8L45 or 8L90. These transmissions can be found in trucks and SUVs like the Chevy Silverado, Colorado, Tahoe, and performance cars like the Camaro and Corvette. The idea was to improve fuel economy and shift smoothness. On paper, it's a pretty good transmission, but what about in real-world driving? A lot of owners run into problems with this transmission, making it one of the features ruining your engine reliability and longevity. Many Chevy owners have reported harsh or jerky shifts, delayed engagement when going from park to drive, and gear lurching. These symptoms often start at moderate mileage, sometimes well before 100,000 miles. And here's the problem. Frequent harsh shifts or delayed gear engagement can stress the internal components. The clutch packs, valve bodies, and solenoids inside the 8-speed are meant to manage 8 gear ratios. And when the shifts aren't smooth, those parts cycle more aggressively. Over time, this can lead to premature internal wear, metal debris in the fluid, and if you don't pay attention, a rebuild or replacement costing several $1,000s. One Silverado owner noticed that his 8-speed started hard shifting between first and second, and even after repairs and fluid changes, he still needed a rebuild. GM has issued multiple technical service bulletins and updated fluid specifications to Dexron HP to address shudder and shift concerns. Some signs that the transmission is having issues include having a lurch when slowing down, delayed engagement from park, and shuddering or vibration under throttle. But this doesn't mean you can't solve the problem. Focus on regular maintenance and using the latest GM-approved transmission fluid, Dexron HP, to reduce wear. Regular checks can also catch leaks or overheating before they damage the internals. If you start feeling clunks, jerks, or slipping, don't ignore them. Get it checked sooner rather than later. These features cover some hidden faults that Chevrolets deal with, eventually wearing on their reliability. But the next few problems are ones you might never even pay attention to. When Chevrolet started leaning harder into small turbocharged engines, like the 1.4-liter turbo in Cruze, 1.5-liter in Equinox, or the 2.7-liter Turbo Max in newer models, the goal was to get good power and fuel economy out of a smaller package. But the problem is that the turbo systems are way more complex than naturally aspirated engines, which means more failure points that can affect reliability and lifespan. A turbocharger sits on the exhaust side of the engine, using exhaust gas to spin a turbine that forces extra air into the engine for power. It sounds like smart engineering, right? Well, in daily driving, especially with frequent short trips or aggressive use, these turbos are under significant thermal stress. A lot of Chevy owners deal with boost leaks, oil seal leaks, and turbo bearing wear on their engine, reflecting in signs like loss of power, whistling or whining noises, and warning lights before turbo failure. Most Chevys with a 1.5-liter turbo engine run into these problems around 80,000 and 120,000 if oil changes aren't maintained and the engine spends a lot of time at lower temperatures, where condensation and carbon buildup are worse. Excessive oil consumption and overheating is common in small turbos, but this accelerates component wear. To make things worse, frequent stop and start traffic cycles and aggressive throttle changes make the turbo work harder and put more stress on the seals and bearings than a simple, naturally aspirated engine. If you don't want to shorten the life of your Chevrolet, then change the oil regularly with quality synthetic oil, check the turbo hoses and intercooler piping for cracks, and let the engine idle briefly before shutting down after highway runs so that the turbo bearings can cool. Now, the next Chevy feature is meant to offer help, only to cause more trouble instead. Chevy introduced the Oil Life Monitoring System with the aim of helping drivers figure out when their oil actually needs changing instead of just guessing based on miles alone. The system is calibrated for each specific Chevy engine, so it should tailor the interval to your driving style. But it often does more harm than good. For owners who have engines with direct injection, AFM, DFM, turbos, or who do severe service, towing, short trips, extreme temperatures, waiting for the monitor to hit 0% can mean the oil is severely degraded. In those engines, oil has to do extra work controlling soot, cylinder deactivation lifters and turbo bearings. If you ignore early signs and run the oil close to zero life, the lubricants and additives in the oil can break down, leading to sludge buildup, lifter wear, bearing wear, and higher oil consumption. That's why I tell Chevy drivers not to trust the OLM as the only guide for changing oil if your driving is severe. Instead of pushing to the warning, consider changing oil on a mileage basis. For example, 5,000 miles for severe use, even if the monitor says you still have life left. You see, Waiting for 0% oil life on the monitor is really designed to be flexible for normal driving, but aggressive use, hot climates, short trips, or heavy towing can degrade oil much faster than the computer predicts. Don't forget this: oil is cheap and engines are expensive. Changing oil before the first dash warning is a good choice, especially in engines with GDI and AFM/DFM. You should check the oil level and condition yourself. There's one Chevrolet setting that can be found everywhere but is known for being overly sensitive or glitchy. The electronic throttle control, ETC, replaced the old mechanical throttle cable. Most drivers don't think twice about it until something goes wrong. What this system does is use sensors and an electric motor on the throttle body to open and close the throttle plate based on signals from your accelerator. The ECU will decide exactly how much air to let in instead of a cable, doing it direct. But there's one main problem: Chevy's implementation can lead to unexpected engine behavior, limp home modes, and stress on driveline parts when the ECU suddenly limits power. A lot of Chevy owners, especially on older Silverados, Sierras, Equinoxes, and Cruise models, have shared stories of strange throttle behavior. In some cases, the truck would run fine 1 minute and then suddenly go into limp mode with reduced power while driving, only to clear itself after a restart. A quick check would reveal that it's because of issues in the throttle position and electronic throttle module. And even after replacing the throttle body and harness, it would crop up again until wiring and grounds were inspected. ETC systems rely on clean, accurate sensor signals from the accelerator pedal and throttle position sensors, and they need stable voltage. But Chevy models always deal with corroded connections, worn throttle motors, or glitches in the ECU logic, all of which confuse the system. If you don't want it to affect the reliability of the Chevy engine, keep the electrical connections clean, use OEM quality throttle bodies and sensors, and pay attention to warning lights or reduce power messages early. A proper throttle body relearn or calibration with a scan tool after cleaning or part replacement will also help. Aside from this system, there's another problem with Chevrolets that often causes long-term issues. Another problem with modern Chevrolet vehicles that sounds like a great convenience is the over-the-air updates. This allows your truck or SUV to get updates while you're parked at home, no dealer trip required. But this often comes with a lot of problems. Inconsistent update installs end up hurting reliability and leaving you stuck, especially when an update fails or your system gets stuck partway through. Chevy's OTA systems are supposed to keep infotainment, control modules, and other software up to date. But a lot of owners deal with situations where the updates stall or never complete. Some owners noticed that the OTA update never finished, and the vehicle wouldn't start afterwards until it was towed to a mechanic. Other owners had problems when an OTA update bricked the entire infotainment and adaptive cruise systems on their vehicle. This can cost over $1,400 to replace the unit after the install fails. Many Chevy drivers run into these issues when the system is trying to install important firmware, but the 12-volt battery isn't strong enough. The update hangs midway through and cellular signal drops. This leaves the modules in a half-updated state and confuses the ECU and instrument cluster. But this isn't a phone or laptop update. A car OTA failure can affect multiple systems at the same time, like the engine management, infotainment, and safety systems, all of which go out of sync if something goes wrong. I recommend making sure your 12-volt battery is healthy and fully charged before accepting any OTA update. Also, don't ignore any update available message for a long time. If the update fails or breaks the system down, you might have to tow your vehicle to the dealer to fix or replace the part. So, for Chevy owners that want long-term reliability, knowing about the hidden factors can make a huge difference in keeping your vehicle dependable.